Hi, welcome back. We have talked about the cubic graph, okay, where we have y equals to ax cubed, okay, and so on. We have talked about the reciprocal graph, where y equals to a over x, or y equals to a over x squared. Okay, now we're going to talk about the exponential graph. Now you might have heard of someone saying that, oh, this thing increases exponentially. Okay, for example, this disease, the number of people infected increases exponentially, which means it increases at a very fast rate. So when I plot the graph, you know what I mean. Okay, when we say that something increases exponentially, which means it increases extremely fast. Okay, and exponential graph is in the form of y equals to a to the power of x. Okay, where a again is a positive real number. Okay, so it'll be something like this. Okay, it will start increasing. Now take note that as x progresses, the value of y will increase at an increasing rate. Okay, now take for example, let's say a equals to 2. A is equals to 2. Okay, so y would be to the power of x. Say x is to the power of 1. Okay, we'll get y equals to 2. If x is to the power of 2, we get 4. If x to the power of 3, we get 8. If x to the power of 4, we get 16. X to the power of 5, we get 32, and so on, 64, and 128, and so on. Note that the rate of increase is increasing. Okay, within here, we get 2. Within here, we get 4. Within here, get 8, within here we get 16, and within here we get 32. So it's constantly increasing at an increasing rate. Okay, it's increasing at an increasing rate. Thus, when we say something increases exponentially, it increases at an increasing rate. One such example is the example of cells. Okay, cells. The cells in your body, they'll multiply at an increasing rate. Right? One cell becomes 2 cells, 2 cells becomes 4 cells, 4 cells become 8 cells, 8 cells become 16 cells, and 16 cells becomes 32 cells. Okay, so such is a real life example of something that increases exponentially. Alright, so say we take the example of a graph y equals to 3 to the power of x. Okay, now observe that there will be no negative values of y for any value of x. What it means is that y can never be negative. Okay, y will be definitely more than 0. Okay, because when we have 3 to the power of x, any number, this will never give us a negative number. Okay, and the other thing to take note for an exponential graph is the larger the value of x, okay, the rate of increase of y will increase increasingly. Okay, it increases at an increasing rate. This is important. Okay, so suppose we have y equals to 3 to the power of x. Okay, we can find a value of y by substituting again the value of x here. So when we say x equals to 0, okay, y would simply be 3 to the power of 0, thus equals 1. Okay, thus we know that this value will be 1. Okay, what about if x is equals to 1? Y would be 3 to the power of 1, which should be 3. So if let's say here is 1, here it will be 3. Okay, although this is not drawn to scale. And if x is 2, y would be 3 to the power of 2, which would be 9. Thus, if x is 2, y, this one will actually be 9. Okay, thus you see y increases at an increasing rate.